All right, so we're going to start with operations with integers. Integers, do you guys know what integers are? So they're the set of whole numbers. Okay? Whole numbers means they're numbers that doesn't have decimal. They're not fractions, right? They're whole numbers. Like when I'm counting objects, right? I count whole numbers, 1, 2, 3, 10, 20, right? So these are examples of, also can be negative, positive, or also includes the number 0, okay? So they are the set of whole numbers, so no decimals, which include positive numbers, negative numbers, and the number 0. Okay? So we write them as a set of, we use the letter I, and then the set could be, let's say, -3, -2, -1, 0, 1, 2, 3, all the way to what we call the infinity. Okay? So for infinity, we usually use this symbol, okay, that represents the number infinity. Infinity is infinity is a number that no one knows what it is, okay, because there's no end to it. There's no end to the numbers, okay? And we usually use for the negative infinity, we use the same symbol, but with a negative in front of it, okay? So this represents the infinity. Okay? So it's a set of whole numbers. Remember, whole numbers means numbers that don't have decimal. They are something that you can, like 1, 2. No decimals, no fractions. Okay? So when adding two integers, so if the signs are the same, then the sum will have the same sign, right? Which means if I'm adding two positive numbers, I'm going to end up with a positive number. If I'm adding two negative numbers, I'm going to end up with a negative number. Yes? Because if I'm adding, let's say, 3 and 5, that gives me 8. If I'm adding -3 plus -5, that's going to be -8. All right? So there are two integers with the same sign. They're both negative, and I'm adding them together. Okay? So anytime you're adding two integers with the same sign, you're going to end up with the same sign as the two integers. If the signs are different, then the sum will have the sign of the bigger number, the larger number, right? So in this case, I'm looking at different signs, okay? So let's look at an example. So if I have, let's say, -8 plus 3, okay? I have two integers. One is negative, the other one is positive. Yes? Okay? Which one is a larger number, 8 or 3? 8. 3 is a larger number if you're talking about a positive 3 and a -8, but we're talking about the absolute value here. So 8 is the larger number, right? Because 8 has a negative in front of it, so your answer is going to be a -5. Okay? So it's going to have the sign of the larger absolute value number. You are right in respect with -8 is going to be lower than a 3. Yeah. If I have, let's say, 8 plus -3, right? 8 is the larger number, right? it's going to be a positive 5 because 8 is a positive number, and that's a larger number. Okay? I know the calculator does give us the answer, but at the same time, it's good to know if your answer is correct or wrong, right? It's just it's for your own knowledge. Okay? When subtracting two integers, add the opposite. What I mean by this is I don't usually like this whole idea, but think about it this way. If you have 3 minus 4, okay? Basically what they're saying here, I'm subtracting two integers, right? I'm subtracting 3 and then I'm subtracting 4. Okay, it's the same thing as writing 3 plus minus 4. Okay, it's exactly the same thing what I'm doing here. Now, do I really want to make it more complicated? I don't. Okay, but basically these mean the same thing. That's what this is telling you. Okay, but we know that a positive and a negative right after each other, that's the same thing as a negative. What would be the answer for this one? Negative 1. Yep. So the answer for this one is negative 1. Okay. Now when I'm dividing or multiplying integers, if the two integers have the same sign, so I'm going to give you an example here. If I'm multiplying a negative 2 times a negative 3, what's your answer going to be? Positive 6, right? So if you're multiplying two that have the same sign, so they're both negative, your answer is going to be positive, right? If I'm multiplying a 2 times a 3, they're both positive, again, your answer is going to be positive, right? So if I'm multiplying two integers that have the same sign, then the answer is going to be positive, right? Negative times negative is positive. Positive times positive is positive. If the two integers have different or opposite signs, so which means one is going to be positive, the other one is going to be negative. So let's say if I have 3 times negative 2, my answer is going to be negative 6, right? So the answer is going to be negative. We're good with that? Most of the times when we're doing math, we're not going to have only two things multiplied together or two things added together. Most of the time, it's a complicated operations, right, where we have multiple operations going on together. We need to know what order we follow to evaluate the expression. Okay? Do you guys remember the acronym that we use for the order of operation? What is it? BEDMAS, that's right. So the acronym that we use to help us remember the order of operation is BEDMAS. We'll go over what that represents. So when evaluating expression, you need to follow what we call the order of operation. It's like in anything, right? When you're cooking, right? You have to mix things together properly before you can put it in the oven. You can't put it in the oven before mixing, right? Or when a doctor is doing the operation, they have to cut open first and then do the work, and then they can't stitch first. You know what I mean? So it's the order of our operation. It's the order that we follow. Same with math. You have to follow a certain order of operation. The acronym for it is BEDMAS. Do you guys know what the BEDMAS stands for? That's correct. Okay, so this is an acronym that we follow here. So B stands for brackets. So you're going to have to simplify inside the brackets first. Okay, so if you have brackets and you have things that inside of it, you have to do the operation inside the brackets first. Then you're going to have to do your exponents. Right, so if I have, let's say, 2 to the power of 3, right, you're going to have to simplify that. You have division and multiplication. Division and multiplication, they can be done, it depends on what order they appear in, okay? So whatever comes first. You don't have to do division first and then multiplication. If multiplication appears first, you have to do multiplication first, okay? So for this one is whatever appears first. Again, similar with addition and subtraction. Technically, you can do these together, and then again in order from left to right. Okay, so this is what BEDMAS stands for. You're going to hear me refer to it, just so you know. It's the order of operation. So if I look at the first example, I have bracket -7 plus 2, close bracket, times 4. Order of operation tells me I have to do the brackets first. Yeah. So I have to simplify inside the bracket. I have to do -7 plus 2, which gives me -5. Usually when I have an expression, I want to start my sentence under the expression. I started with an equal sign. That's why you see me, I deleted that equal sign from here. So the correct way to write this is to start a new line with an equal sign. Okay. And then I do the bracket, so that's going to be -5 times 4, right? And then my next operation is multiplying the -7 times the 4, okay? Or -5 times the 4, sorry. Okay? And something that I want you guys to focus on is your brackets. Brackets are important. They mean something. We don't put them there for decoration, okay? They mean something. They represent something. You can't just add them randomly, and you can't remove them randomly, okay? You have to treat them with respect. All right. So if you look at the second one, it's another expression. So I have 3 plus 60 divided by 2 squared multiplied by 5 minus 4. Do I have any brackets in here? No. So I skip the brackets. Where do I go next? The exponent. So I have to evaluate the exponent. Where is my exponent? 2 squared. So everything else is going to be the same. So I won't change that. I just have to evaluate 2 squared. Okay. After the exponents, what do I do? Division or multiplication, whatever comes first, yes? So in this case, I have to go from left to right. We read from left to right in English. So if I'm going from left to right, which one comes first, division or multiplication? Division. So I have to perform the division, which is 16 divided by 4. So that is going to be 3 plus 16 divided by 4, so that's 4 times 5 minus 4. Okay? Followed by So you see that I have 3 plus 16, then divided by 4 times 5 minus 4. Okay? After the exponent, I have to either do division or multiplication, whatever comes first. So in this case, if I'm reading from left to right, the first thing that comes is division, right? Between division and multiplication, the first thing I see is division. So I have to perform the division first. So I have to do the 16 divided by the 4 first. Okay? Then, the multiplication, right? Now I see that I have a multiplication 4 times 5. So I have to do 3 plus 20 minus 4. Okay? Now all what I have is addition and subtraction, right? I can do them all together. I don't have to actually do multiple steps. So this is going to be 3 plus 20 is 23. Take away 4. That is 19. And that is my final answer. Okay? If you don't follow that order and then you do whatever you wish to do, you're going to end up with an ugly number that is not going to even be close to correct. Okay? So please be careful with your order of operation. Okay? Next expression. So I'm going to have to simplify brackets. In this one, because it's a fraction, what we have to do the top, simplify the top, simplify the bottom, right, separately, and then do the division. Okay? So we're going to treat each, the numerator by itself. We're going to treat the denominator by itself, and then do the division. All right? So if I look at the top, we call that the numerator. If I look at the numerator, what do I do first? I have to do the division, right? If I had this, then you do the addition, okay? But because there's no brackets there, you can't do that. You see that in this case, I have 24 plus, I have the negative 12 divided by the negative 3. This has to be done first, all right? So that's going to be 24 plus. What's negative 12 divided by negative 3? 4. And it's positive because I'm dividing two numbers with the same sign, yes? Okay. In the denominator, what do I have to do first? The bracket in this case, right? Remember, brackets, inside the brackets has to be simplified first, okay? So that simplification I have to do first, so that's going to be, what's negative 4 plus 12? Positive 8, yeah? Divided by negative 2. So I can simplify my top. What's my top? 28. And then for my denominator, now I have 8 divided by negative 2, which is negative 4. Right? Now my numerator is simplified all the way. My denominator is simplified all the way. All what I have to do is my division. 28 divided by negative 4. Negative 7. Okay? You can try it in different ways. You're going to get the wrong answer, right? There is something, I don't know if you guys have seen these on social media where they give you like a question and then they tell you like 1 in a million will not get this, like only 1 in a million will get this right or whatever. I've actually have tried few of them, and it's the bed mass, right, that gets some people. But the problem is that the calculators, we've tested calculators with exactly the same thing, and they give you different answers. Okay, it's not people, it's the engineers or the mathematicians who have programmed these calculators, right? Because what happens sometimes if you do this, let's say, I don't know if that's going to give you a different answer or not, But sometimes the calculator will take this, the brackets multiplied together is going to take them differently than if I have this kind of multiplication. Okay? Sometimes some calculators take this differently than this. Okay? And they treat the brackets differently. I don't remember what was the question that was asked. And then one calculator gave an answer of +9 and the other calculator gave an answer of -1. Right? Technically speaking, one of the answers is more correct than the other if I work backward. But be careful with the calculator. Sometimes it gives you the wrong answer per se. It can be, like, I can argue both answers, right? I can argue both answers, but the minute you work it backward, one of the answers is correct, not both of them, okay? And the reason for that is just because one is designed by an engineer and the other one is designed by a mathematician, okay? And engineers, they like to work differently. All right, so let me